You ever stop and really think about what's happening when ice melts or a puddle just vanishes on a hot day? It looks like a simple disappearing act, right? But it's actually this incredible dance of energy happening at a level we can't even see. So today, let's dive into that. We're going to climb what I like to call the energy ladder to see how the very stuff around us changes from one state to another. So let's start with a little riddle. What in the world connects a melting ice cube, your wet t-shirt drying on the line, and the dew you see on the grass in the morning? I mean, they seem completely unrelated, don't they? But the truth is, they're all the exact same process in action, matter changing its state. And it's all powered by one single thing, energy. Okay, so to really get how these changes work, we got to go back to basics. We need to get a feel for the three main states of matter that make up, well, pretty much everything we interact with every single day. Think of it like this. In a solid, all the tiny particles have very low energy. They're all locked into a tight grid, just kind of vibrating in place. Now, give them a little energy boost, and you get a liquid. The particles can now break free and slide past each other. Then, pump in a ton of energy, and you get a gas, where the particles are just going wild, bouncing all over the place. It all comes down to energy and how much freedom those particles have. Now, here's the most important thing to remember. When matter changes state, it's a physical change, not a chemical one. Ice, water, and steam are all still H2O. Nothing new is created. And because it's just about adding or taking away energy, the whole process is totally reversible. You can climb up the ladder, and you can come right back down again. All right, let's start climbing. We're going to turn up the heat, pump some energy into the system, and see how a boring old solid can transform into something way more exciting. The first rung on our ladder is melting. It's that classic transformation from a solid into a liquid. And you've seen it a million times, right? An ice cube sitting on the counter slowly turning into a puddle. The warmth in the room is all the energy it needs to make that jump. But here's where it gets really cool. While that ice is melting, its temperature is stuck at exactly 0 degrees Celsius. It doesn't get any warmer. So where is all that heat from the room going? It's being used as latent heat, which basically means hidden heat. This is the energy that's busy breaking the bonds holding the solid together, letting the particles finally flow as a liquid. It's like the price of admission to get to the next level. And yeah, for water, that magic number is 0 degrees Celsius, 32 Fahrenheit. At that exact temperature, you can have both solid ice and liquid water hanging out together in perfect balance. It's pretty wild. Okay, time for the next step up the ladder. We've got our liquid. Now we're going to pump in even more energy to push it into a gas. This whole process is called vaporization. You know, vaporization actually comes in two different flavors. You've got evaporation, that's the slow, quiet one. It just happens at the surface, like when a puddle slowly vanishes on a warm day. Then you've got boiling. That's the loud, rapid, energetic party that happens all through the liquid once it hits a very specific temperature. And for water, that boiling point is, of course, 100 degrees Celsius or 212 Fahrenheit. This is the moment when the water has absorbed enough energy, including another big dose of latent heat, to finally break free completely and become steam. We've made it to the top of the common part of the ladder anyway. But hey, what goes up must come down, right? This energy ladder is a two-way street. So now, let's start taking energy out of the system and watch everything descend from those high energy states. The first step down is called condensation. This is what happens when a gas cools off. Its particles lose energy and they start clumping back together to form a liquid. Just think about the water droplets that form on the outside of a cold drink on a summer day. That's water vapor from the air hitting the cold glass and turning right back into liquid. And this shows just how perfect the cycle is. That latent heat that the water absorbed to become a gas, it doesn't just disappear. During condensation, that exact same amount of energy gets released back into the environment. It's a perfectly balanced system. Energy in, energy out. All right, the final step back down our ladder is freezing. As a liquid keeps losing energy, its particles slow down more and more until they finally lock themselves into a fixed, orderly structure. They become a solid. It is the perfect opposite of melting. So we've talked about going step by step, but what if you could just take a shortcut? It turns out nature has some really cool exceptions where matter can completely skip the liquid phase, jumping directly from a solid to a gas, or vice versa.
The upward jump, solid straight to gas, is called sublimation. The best example is dry ice. You'll notice it never melts into a puddle. It just creates that smoky fog as it turns directly into carbon dioxide gas. The reverse trip from a gas straight to a solid is called deposition. You know that beautiful, intricate frost you see on a cold window? That's just water vapor in the air turning directly into tiny ice crystals. No liquid involved.
So we've done solid, liquid, and gas. And you might be thinking, that's it, right? Oh, not even close. What happens if you just keep pumping in more and more energy? If you climb past gas, well, you get to a fourth, super energized state of matter, plasma. To make plasma, you have to hit a gas with an absolutely insane amount of energy. We're talking lightning bolt levels, or the core of a star. You hit it so hard that the electrons are literally ripped away from their atoms. What you're left with is this soupy sea of charged particles. And that is plasma. Now, it might sound super exotic, but plasma is anything but rare. Get this, it is the most common state of matter in the entire universe. And when you think about it, that makes total sense. The universe is full of stars, and stars are just gigantic balls of plasma. Our own sun, every bolt of lightning, even the northern lights, that's all plasma doing its thing. So that kind of brings us to a final thought, doesn't it? We live our lives surrounded by solids, liquids, and gases. But if the universe's default setting is actually this super high energy state of plasma, it really makes you wonder, what other incredible transformations, what other bizarre states of matter are out there happening on scales we can't even imagine?